Okay, so the question we are going to be looking at today is find the sum of the geometric series 4 plus 12 plus 36 plus 2,916. So the first step in approaching a problem like this is finding the given values. So in this case, A, R, T, N, and N. So A is 4, which is the first term in the series. R is the ratio in which each term is being multiplied by, and this is 3. So our Tn value is the last term in the series, which is 2,916, and our n value is unknown. So if we look at our geometric series formula, we do not have enough information here so that there's only one variable to solve for. So we need to take a step backwards and look at our geometric sequence formula, which is Tn equals a r to the power of n minus 1. So what we're going to do now is plug in all of our values into this formula in order to isolate for n. So Tn equals 2,916, a equals 4, r equals 3, and n is our unknown value, minus 1. So now what we're going to be doing is just isolating for n. So we're going to divide both sides by 4. That cancels out. So this is equal to 729. So then this just comes down. So now what we're going to be doing is finding an exponent that equals to 729 with a base of 3. So in this case, it's going to be 3 to the power of 6. So now, since both the bases are the same, we can cancel those out. So it's going to be 6 equals n minus 1. Now we're going to isolate for n. So we're going to move negative 1 to the other side. It's going to become positive 1. So n equals 7. So now, since we have our n value, a value, and r value, we can sub in those values to this equation. And there's going to be only one variable we need to solve for, which is the sum. So we're going to plug in 4, 3, 7 minus 1 over 3 minus 1. And then I'm just going to solve. So 3 to the power of 7 equals 2,187 minus 1 over 2. So this is equal to 2,186 over 2. So if we multiply those two values together, it gives us 8,744 over 2. And if we divide that, we get 4,372. So that's how we find our sum value of a geometric series.
What my unit is 6.6, which is arithmetic series. What arithmetic series is, it's basically finding the sum of all the terms in arithmetic sequence. If the arithmetic sequence is 2, 4, 6, 8, and 10, then the series would be 2 plus 4 plus 6 plus 8 plus 10 and so on. The formula is Sn equals n divided by 2 bracket 2a plus d n minus 1 bracket, where Sn is the sum of the terms, n is the number of terms, and a is the first term, and d is the common difference. Another formula would be Sn equals n divided by 2 bracket a plus tn, where tn is the last term. Talking about is the communication question. Find S15 given that T2 equals 8 and T10 equals 32. Do not solve and write down the steps. Step 1 would be to sub in T2 equals 8 and T10 equals 32 into the Tn equals a plus n minus 1 bracket d formula to find. And then afterwards, step 2 is using the process of elimination, subtract T10 equals 32 by T2 equals 8 in the formula of Tn equals a plus n minus 1 bracket d to get the value of d. Step 3 would be to sub in the value of d into one of the Tn equals a plus n minus 1 d Formulas to find the value of A. Step 4 would be to sub in all your values, the A value, N value, and D value into the Sn equals n divided by 2 bracket 2a plus d bracket n minus 1 bracket formula to find the value of S15. And this is how you would solve the question.
Hi everyone, I'm Natalia, and today I'm going to be talking about geometric sequences. So this is Unit 6.5. A geometric sequence is a sequence that has a constant ratio of consecutive terms. For example, 2, 4, 8, 16. In this sequence, since it's geometric, it has a common ratio. So a common ratio is what the sequence goes up by. So common ratio. And to find it, you could just divide a term by the term before it. So you get 2. 16 over 8, the term and the term before it, equals 2. So your common ratio is 2. 2 times 2 equals 4. 4 times 2 equals 8. 8 times 2 equals 16. So the geometric sequence has a formula, which is Tn equals ARn minus 1 as a power. The A represents the first value. So your A equals 2. Your R represents your common ratio, which your sequence goes up by. So your R equals 2 as well. And your N is the number of terms. And your Tn is your term number. So they will give you your Tn and N, or you have to find one of them. And then you subtract 1 from your N. And today I'm going to be teaching you how to solve a geometric sequence application question. Okay, here's the question. Chad, a champion show dog, had 2 parents 1 generation ago, 4 grandparents 2 generations ago, 8 great-grandparents 3 generations ago, and so on. Here's question A. Write the general term of the geometric sequence that represents this situation. First, let's understand what this question is talking about. So, Chad had 2 grandparents 1 generation ago, 4 grandparents 2 generations ago, and 8 great-grandparents 3 generations ago. So we have our T1, our first generation, which is 2 parents. We have our T2, 2 generations ago, which is 4. And we have our T3, 3 generations ago, which is 8. So the generations represent n, our value of n, and 2, 4, 8 is our geometric sequence. So we have 2, 4, 8. This is the sequence we have. Because it is a geometric sequence, we know that the equation we are going to be using is AR n minus 1 as a power. This is the equation we're going to use, geometric sequence. Very important, they even told us about it. So first, we're going to see which values we have. Right now, we have A. Yes, A is the value of the first term within the sequence. We have R, we can find R. To find R is very simple. You use it, you get a term, and you divide it by the term in front of it. So 2. 4 divided by 2 is 2. If you want to double check for the next one, you do 8 divided by the term before it, 4, which is also 2. So our common ratio, R, is 2. And then that's basically it because it's our general term. Now we plug in the values we found into the equation. So we have Tn equals 2 multiplied by 2 with a power of n minus 1. And this is our general term. And this is how you solve A, just for the general term of geometric sequence. Let's move on to B. Determine how many ancestors Chad had each number of generations ago. So because they are asking how many ancestors Chad had, we are trying to find T. And they gave us the number of generations ago, so they gave us our n value. So let's try it. For the first one, we have 6. So n equals 6 because they gave us it. So we are trying to find T6. So T6, we're going to use our equation we made in A. So we have T6, 2 times 2. We're going to plug in n to where it belongs. So up here, 6 minus 1. So T6 equals 2 times 2. 6 minus 1 equals 5. T6 equals 2. And 2 to the power of 5 equals 32. You're going to multiply these two. So T6 equals 64. 6 generations ago, Chad had 64 ancestors, and that's all you do. They gave you the value, and you're trying to solve for another value. So they gave you n, you're solving for Tn, because Tn represents ancestors, n represents generations. So let's try the next one. So they're saying n equals 10, so 10 generations ago. So we're trying to find T10, which equals 2. So same thing before, we're using the same equation from A, and we're plugging in n with a different value. 2, so here's n, 10 minus 1, 10, because that's our n that they gave us. T10 equals 2, 9, because 10 minus 1. T10 equals 2. 2 to the power of 9 is 512. You're going to multiply those two, so you get T10 equals 2 times that. 2 times 512 equals 1024. 10 generations ago, Chad had 1,024 ancestors. It's simple like that. They gave you the values that you needed, and you just solve for one. And for it, it's very simple because we made our general term in A, and we just use it in B as well. So let's try the last one. N equals 14. So same as the other two, we're just plugging in n with a new value, but using the same equation. So T14 equals 2 times 2 to the power of 14. Here's our n, minus 1. 214 equals 2 to the power of 2 multiplied by 2, minus that equals 13. T14 equals 2. 2 to the power of 13 equals 8,192. And then we are going to multiply those two. So 214, which equals 16,384. And this is it. So 14 generations ago, Chad had 16,384 ancestors. And that's all you do for B. So we solved all those three. Let's move on. How many generations ago did Chad have 8,192 ancestors? So this is a little different. Instead of giving us the value n, they gave us the t value. So we have the tn value, which is 8,192 ancestors. And they're asking us how many generations ago, which means they're asking us to find n. It's the same as B. We're just switching the values that they gave us and switching the type of values we are plugging in. So we're using the same equation from A and the same equation we used in B. So because we have Tn now, we are going to plug that in. 8,192 equals 2 multiplied by 2n minus 1. Because we don't have n, we're solving for it. Divide each side by 2, so this 2 and this 2 can cancel out. 8,192 divided by 2 equals 4,196. Because those two cancel, so now we only have Tn minus 1. Because this is an exponent, we are trying to separate it from 2, so we're going to use logarithm. So we have log 4,196 equals log 2, and now we bring down the n minus 1. We're going to divide each side by log 2, so this could cancel out, so we could just have n minus 1. So we have a log 2, and then log 2. When this divides log 4,096 divided by log 2, that gives you 12. And because these two cancel out, you have n minus 1. You're going to move the n to the other, the 1 to the other side. Simple. 12 plus 1, because it's negative, turns to positive over here, equals n. 13 equals n. 13 generations ago, Chad had 8,192 ancestors. And that's how you solve C. It was the same as B, we just had different values to plug in. And that is basically how you solve this geometric sequence application question. Thank you so much for listening. I really hope you learned something from this.
This is a thinking question from chapter 6. The question is, given the geometric sequence 5, x, y, and 135, determine the values for the unknown variables x and y. And these are all the formulas that we know so far. So since it says it's a geometric sequence up here, we only use the equations that have the r, and don't use the equations that have d. So we won't be needing this one, won't be needing that one, and yeah, we'll need the others. So now the next step is to find out what r equals. In order to do that, we could, this is asking for the sum of the equations, these two, so we won't be needing this or this, and we'll have to work with this equation. And to find r, we're gonna start with T4, which is up here given, it's 135. And now we sub it into this equation. So T4 equals A R n minus 1, and now n we substitute for, so it's going to be T4 equals A R 4 minus 1, and A value is the initial value, which is 5, so we could substitute 5 for A. So 5 R and then 4 minus 1 is 3, so power to 3 equals T4, and T4 is our fourth number, which is 135. So 135 equals 5R cubed. And now we divide both sides by 5. That will give us 27 equals 5R cubed. 27 equals R cubed. And as we know, 27 is basically 3 to the power of 3. And when the powers are the same, we could compare the bases. So it's going to be, R is going to be equal to 3. And now, since we found R, we could easily find T1 and T2. So we use the same equation that we used up here, and sub in T2 equals A is 5, R is 3, and N is 2 minus 1. So T2 equals 5 multiplied 3 to the power of 1, which is 15. And since up here in the example, in the sequence that they gave us, T2 is x, so we know that x is equal, x is equal T2, and T2 we just found out is 15, so x is equal 15. And now back here at the bottom, we're looking for T3 now, which is y. It's the same equation, a r to the power of n minus 1. So a is 5, r is 3, n is 3 now, and minus 1. So T3 is equal 5 times 3 to the power of 2, which is 5 times 9, and that's going to be 45. So we found the y value, which is 45, because T3 equals y. So this is our sequence: 5, 15, 45, and 135. And to check our work, you could check by doing this. Since we have the r value as 3, you multiply 3 to the first T1, and you'll get 15. And 15 times 3, you'll get 45. And when you multiply by 3 again, you get 135. Thank you for watching my video. I hope you enjoyed it.